I'm Haley Shanahan. I'm Felicia Knight. I'm Caitlin Melanson.
And I'm Arthur Grant.
And we are Flags of the Future. Wind has the power to damage, but what if we could turn that potentially destructive force of nature into a usable source of energy? We believe taking advantage of wind, which is a worldwide resource, could be the next step in conserving energy and not using up fossil fuels. We want to put our product in hurricane-prone areas to harness and utilize the strong winds that occur. Here's Caitlin with our product.
Our product is called the Vexivigor. Vexi is derived from the Latin term vexillum, which means flag. Vigor is a Latin word that means force or energy. This is an exact definition of what our product is. A flag that transforms energy. Here is Scotty with our idea.
Our idea is to harness wind energy and activate a flag with electromagnetic components to be a backup source of energy for hurricane-prone areas and areas of people in need. An electromagnetic generator, like the one in this picture from Macacao Communications Museum, shows that when a magnet passes by a copper coil, it induces electricity. This flag takes ideas from other generators, but has brought these components together in an unprecedented way. Now to Caitlin with her inspiration.
Upon our research to find if there was anything out there like our idea, we found nothing like the Vexivigor. However, we found things that inspired us along the way. One of which is wind turbines. Another was wind farms such as fresh hills, a lower to the ground, landscape isolating wind farm. And then the Vexivigor is very convenient because it's exactly like owning a regular decorative flag, except with the added benefits of reducing the cost of your electric bills, and unlike wind turbines, they are quiet. For a functional prototype, we spent a little over $100 making our product cost-effective. Here's Scotty with our prototypes and experience.
The definition of experimenting is to perform a scientific procedure to determine something, and that is exactly what we have done. Through experimenting, we have determined what will be best for the flag, such as placement, shape, size, and a suitable fabric. In the end, we came up with this. This is a homemade prototype for the Vexivigor. The flag itself is made of a bed sheet, with cloth sewn over it. It is roughly the size of a household bed pillow. Inside is a triangular frame made of lightweight PVC tubing, aluminum brackets, and thin flat steel that hold the components of our electromagnet. This video shows the theory of our design is actually functional. I'd like to hand it off to Felicia, who will talk about our logo.
So this is a depiction of the emblem we would like to use for the branding of our product. It combines the image of a power button and a flag, which represents our flag transforming wind energy into electrical energy. One of the many directions in which we'd love to take our product is to distribute it around the globe. This would mean that there could be small but significant amounts of energy produced to help developing countries begin to use electricity, from a hut in the Philippines to a home in the suburbs. The Vexivigor will not produce the carbon emissions that fossil fuels do. Fossil fuels are also costly, where the initial cost of our flag would be the only expense. Haley will now start to speak about our plans for funding.
With medium funding, we plan to build a fully functioning prototype. We would be able to purchase all necessary material for the Vexivigor, including the best canvas, the lightest but most efficient wire, and the most powerful magnets in a reasonable size. Here's Felicia with medium funding.
With a medium amount of funding, we would take our idea a step further. We plan to test for the best way to store energy. Some of the forms of storage for wind energy we have looked into are compressed air energy storage, batteries, and hydrogen fuel cells. Compressed air energy storage converts wind energy into compressed air, which can be used to produce energy later. Batteries use the generated electricity to charge the batteries for future use. Hydrogen fuel cells involve splitting water molecules by electricity produced by the flag. Our further research would help determine the cost, efficiency, and accessibility of each of these storage methods. Now to Arthur for our plans for maximum funding.
With this stage of funding, we will look into different forms of design, such as LED lighting in the flag or LED lighting around the pole, both of which would be powered by the flag itself. We would also explore different options for distribution of our product to the public.
tragedy into sustainable triumph.
Thank you all for listening to our presentation.